Okay, Unit 10.1, Beginning of Trigonometry. So today's do now, we are looking at a pizza, a very familiar round shape. We measure, previously, any angles we measure are in degrees, right? How many degrees are in the entire pizza? There's 360 degrees in any circle. Half the pizza is 180. One of these slices of pizza, since there's 8 slices of pizza in a complete circle, the way this has been sliced up, it's 360 divided by 8, which is 45 degrees. The remaining pizza in the graphic, well, there's 1, 2, 3, 4, 5, 6 slices with a couple missing here. So it's going to be 6 times 45 is 270 degrees. So today's lesson is going to focus on radians. It's a different way to measure angles, and in trigonometry, radians is pretty much one of the more important ways to measure angles. So a radian is the angle made by taking the radius and wrapping it along the edge of a circle. Let's take a look at an animation for this. Okay, here's a nice website where it shows you when you take the radius and you wrap it along the outer edge of the circle, then this actually creates an angle that is exactly 1 radian. How many degrees are in a radian? Well, if you take this slice and you double it, triple it, you almost have a half of a circle, which is 180 degrees. Now there's a little more left over, and that's actually the 0.14159 of pi. So pi radians is half a circle. And we also know that 180 degrees is half a circle. So now we have our unit conversion. 180 degrees equals pi radians. Let's take a look at our first example. We're going to convert 72 degrees into radians. So we're going to use the fact that we know that pi radians is equal to 180 degrees. So we set it up this way, 72 degrees. And we set it up like this because degrees cancel with degrees, and you're left with radians. So now we have 72 pi radians divided by 180. Now, we always want to reduce our fraction, and you always want to express your answer in terms of pi. So we need to basically take 72 over 180, reduce it, and put pi back in. So let's go ahead and reduce the old-fashioned way. We have 72 over 180. We'll do half of each, divide by 2, divide by 2. I'm going right to left. Sorry if that bothers you. We have 36 over 90. If I divide out a 9, then I have 4 over 10, which reduces to 2 over 5. And now we put the pi back in, and the answer is 2 pi over 5, or 2/5 pi. Now I want to show you that you can also do this on the calculator. So here's a screenshot of the calculator. If you take 72 divided by 180, then it can actually do the reduction for you. So this gives you 0.4, and all you have to click is the math button, and then the FRAC, the frac option, and that changes it to 2/5. So the final answer, just like what we got the old-fashioned way, is 2/5. Put the pi back in, and there's the answer, 2/5 pi, or 2 pi over 5. Let's go and take a look at example 2. 198 degrees times pi radians over 180 degrees. The degrees cancel out. We're left with 198 pi radians over 180. Final answer is 11 pi over 10. Notice that there's no units down here. No units means radians. Here's example 3. Example 4, even though it's negative degrees, you do it the exact same way. Example 5. All right, now we're converting from radians to degrees. So like I said, no units means radians. So this time we're going to take our fraction of 180 degrees over pi, whereas previously it was pi over 180. Notice that the pi's cancel out, and we're left with 7 times 180 over 3, which we can multiply on the calculator and we end up with 420 degrees. Same thing with example 6. Example 7, same deal, and example 8, just because it's negative, you treat it the same way. You end up with the negative degrees. Tonight's homework looks like this. Here's number 1 and number 2. Number 3 and number 4. Now this graphic right here, this clock, actually goes with number 3. Number 5 and number 6. Number 7, number 8. Number 9 and number 10. Now I want to just spend a little time looking at number 3 because it's a frequently asked question. What is the radian measure of the angle formed by the hands of the clock 2 p.m.? Well, you need to realize that 2 p.m. looks like this. Let's see if I can draw on this. No, it's not letting me. Well, anyway, I'll explain to you. So 2 p.m. is basically the hand goes here and the hand goes here, right? The shorter hand goes to the hour and the minute hand goes to the 12. And I'll go ahead and just draw these in. I put it back in the Smart. And there we have it. And now you can also see that there are 12 of these sections. So let me just section this off again. There are 12 of these sections in a clock. And we know there's 360 degrees. So we take 360. Divided by 12. Each one of these sections is 30 degrees. So I know that the hands of the clock that form 2 p.m. is really 60 degrees. So the question is, how do you express 60 degrees in radians? So that was a hint on number 3 of the homework. Good luck to you.